Hi GOH, this is Unit 2, Lesson 8. Today we're going to talk about congruence in terms of rigid motions. So this is a big concept for Common Core geometry. So I'm going to read from the top a little bit. You have learned in the past that two geometric shapes are congruent if they have the same shape and the same size. The symbol that we use for congruent is that equal sign with the little squiggly over it. The equal sign, which indicates the same size, and the similarity sign, which is the little squiggly part, indicates the same shape. So in exercise 1, we're looking at two triangles, picture below. They're telling us that they're congruent to each other. We're not going to use tracing paper to verify, but if you cut out one of these triangles, you could put it on top of the other triangle. It is a little bit tricky to figure out what vertices correspond to each other, and if I actually did cut it out and place it on top of the other, it might make it a little bit easier to do. But the A is pretty easy. If we look at A, okay, the A corresponds to angle E, so the A matches up to the E. The C, which is right here, does not match up with the D. I don't know if you guys can see, but the AC is a little bit shorter than AB, and EF is a little bit shorter than DE, so the C actually matches up with the F. And that means that the B matches up with the D. And if we took out, if we cut this out and we placed it, we would see that I would have to actually flip it around. So the formal congruence statement, I got triangle ABC is congruent. Now when we're doing this, if you were doing it on the regions and you didn't do it correctly, that would be okay. But if they give you a question, the order of the letters tells you what matches up with what. So I'm going to try and match those up right now. So triangle ABC would match up with triangle EDF. Okay, the definition of same shape and size has worked fine up until now, but now we're going to introduce a very formal definition of congruence. And that definition of congruence is two figures are congruent if there's a sequence of rigid motions that maps one onto the other. Okay, so two figures are congruent if there is a sequence of rigid motions. It could just be one, but it could be more than one, so that's why I'm going to say rigid motions that maps one onto the other. Basically, the figures would coincide with each other and one would lie on top of the other. All right. Question 2. Why does this formal definition of congruent make sense when considering the middle school definition of congruent as same size and shape? Remember, a rigid motion, we learned, preserves the size and the shape. So if two figures are identical, if a rigid motion has produced one from another. Okay, so now we have this concept of rigid motions. Rigid motions preserve size and shape. So it makes perfect sense that that word rigid motion is in our new definition for congruence. So rigid motions preserve size and shape, so the two figures will be identical if a rigid motion has produced one from another. Okay, so this is a formal definition of congruence up there. In this lesson, we're going to be given two congruent shapes, and we're going to try and identify the rigid motion that maps one figure onto the other so they coincide. And this will be something that you might be asked on the regions as well. So the first one's actually pretty easy. In the following diagram, triangle ABC is congruent to triangle DBC. Describe a rigid motion transformation that would map ABC onto DBC. Explain where each of the vertices on ABC get mapped to and why. So remember, I told you the order of the letters tells you what matches up with what. So the A is matching up with the D. Let me get a different color here. The B is matching up with the B, and the C is matching up with the C. So my question to you is, Did you translate this, which means you shifted or slide it? Did you rotate it, which means you turned it? Or did you reflect it? The only way that the A is going to match up with the D down here and the B stays the same and C stays the same is if I actually did a reflection and I flipped it over line BC. So I reflect triangle ABC across BC. That is the rigid motion. When I do that, B maps to B, C maps to C, and A maps to D. The reason that the B and the C stay the same is because they're on the line of reflection, so they're not moving. This one's not too bad. Sometimes it gets a little tricky that a reflection and a rotation look a little bit similar, but you can see here just by the order of the letters and what's mapping to what is actually going on. So let's try another one. So if I flip it over, next page, exercise 4. In the diagram below, triangle TRS is congruent to triangle TUV. Give a rigid motion that maps TUV onto TRS. Use tracing paper to verify your transformation. So we're not going to worry about the tracing paper part of it. But let's look at the order of those letters there. And let me make this a little bit smaller. So I'm going to start with T. T stays on T. All right, so T's not moving. T's staying exactly where it is. Then we'll start with R. R maps to U. So R maps to U down here. And the last one, I have S maps to V. S is over here, and it maps all the way to V. So the question is, T stayed the same. How did R go to U, and how did S go to V? Did I rotate this, or did I reflect it? Now, we're always reflecting over a line, and I'm rotating over a point. So since T stayed on T, I'm rotating about point T, okay? And how much did I rotate? In order for S to go to V and R to go to U, you rotated, and you should say what you're rotating. I rotate triangle TUV 180 degrees about point T. Okay, so just so you could see exercise 3, we had a reflection over a line, and exercise 4, we had a rotation. Now these were easy, and these were just a single transformation, so that definitely made it a little bit easier, but they were easier because they were touching. Now look at this next one. They definitely become more difficult when you have more than one rigid motion going on, and also if they're not touching each other. So we have to figure out in exercise 5 a sequence of transformations that would map the triangle MNQ, so that's this one right here on the left, to right triangle WXY. Be as specific as possible in describing your transformation. There are many correct sequences, and we're not going to use the tracing paper to do that. But here's the first thing that I would suggest. The first thing I would suggest is they have to touch each other. So I'm going to take point N, and I'm going to translate it. So you're going to translate triangle MNQ. So N maps to, oops, that was messy. So that N maps to X. Okay, so I'm going to take this triangle and I'm going to translate it down in that direction and that length so that N maps to X. Now when I do that, let me draw a new triangle down here. And this isn't going to be perfect, but N is now down here. Okay, and it looks like if I was just to take this and shift this down, my triangle would now be down here. Okay, so the Q would be down there, the M would be down there, and the N is touching right there. So that's the first step. The second thing I want to do, I can't really rotate it about that point so that it matches onto that. I'm going to need 2 more steps. I want to rotate this triangle, okay, so that this whole side is touching, and I'm going to run out of paper right here, but I want to rotate it so that it's like this side is going to go all the way over here so that they're going to share a side and that the triangle is actually going to be off the page. But I want to rotate triangle M prime N prime Q prime about X counterclockwise. And actually, I probably don't have to put that in because all of my rotations are counterclockwise. So that M prime maps to W. All right. And I could say by this angle right here, I'm going to rotate it by angle Q prime, N prime, Y prime. Okay, so that's the angle that I'm going to rotate it so that the M prime matches up with that W. Now that they're touching, I'm sort of back at exercise 3. That was the easy one. The last step is just to reflect it over. So I'm going to reflect triangle M double prime, N double prime, Q prime over XY. So here's the steps of what you want to do if they're not touching. You want to translate it so the triangles are touching. If you can't reflect it at that point, you want to rotate it so they're sharing a side. And then once they're sharing a side, then you just reflect it over that line and one would map onto the other. When it's in a graph, that's a little bit easier to do. So let's describe a sequence of transformations that would map ABC onto DEF. Explain why this shows that the triangles are congruent. Now the first thing that you want to look to is you want to look to see if the orientation, the order of the vertices, the orientation on this one, look at triangle on the left, start at A and go clockwise. It goes ACB. Look at the other triangle, start at D and go clockwise. It goes DEF. The order of the vertices has changed because this one was ABC and this one is DEF. So ABC is a counterclockwise and DEF is a clockwise. So the orientation is different. Anytime the orientation is different, there had to have been a reflection. So you just want to see, look for the obvious ones. Did I reflect it over the x-axis or did I reflect it over the y-axis? Now maybe it will help. I'll do this. A maps to D. So the A maps to D. The B maps to E. Where's my B? B maps to E. And last one is C maps to F. All right, so see how C's on top and F's on top and they match up. B's on top, on the bottom, and E's on the bottom, they match up. So I did not reflect this over the x-axis. I didn't flip it. But see how A is on the left and what it matches up to D is on the right? That means I reflected it over the y-axis. So you reflected this over the y-axis. That's the first thing that you did. And then I would actually just reflect it over the y-axis. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. Here's my new one. Okay. C is 1, 2, 3, 4. So C prime is 1, 2, 3, 4. Here's C prime. Because once you reflect it, then you're going to be able to see 5, 6, 7, 8. 8 is 8 away. 6, 7, 8. You'll be able to see what you need to translate it. That's going to be the last step. So first thing is see if the orientation has changed. That means that you did a reflection. And see how everything is perfect now? Everything's in the right spot. I just have to shift it up and a little bit to the left. So I'm going to go to the left 2. I'm going to do a translation in -2 and up 6. And remember, when I do this composition, the thing on the right is the thing that you're doing first. Now, are these triangles congruent? Absolutely. The reason that they're congruent is reflections and translations are both rigid motions. And they preserve the length and the angle measure, so the triangles are congruent. Reflections and translations are both rigid motions. Preserve length and angle measure. So triangles are congruent. There is more than one answer. This is not the only answer. You could have reflected it over any vertical line would have worked, okay? And then your translation would have been different. But this is the easiest and I think the most direct. All right, so we're going to practice some more of that tomorrow.